Philippines. Now I will be able to continue solving of colligative property. Okay, one of the topics, okay, I've done yesterday, okay, polarity. Okay, most of you per letter, so point elevation and the freezing point elevation. Okay, in the boiling point elevation, it will increase, we will add a non-volatile solute. Okay, and then the boiling point is inversely proportional to the case. So now let's take some examples. Okay, great. So start with boiling point elevation. Okay. Okay. You have to play the other videos also. Okay. Here's that. Okay. Boiling point, right? Boiling point elevation. Oh, I think I have an example for that. The boiling point elevation. Boiling point elevation. So our formula will be, okay, boiling point or delta TB, okay, of the solute, okay, or the boiling point elevation or the boiling point of the solute is equals to the boiling point constant TB, okay, the boiling point elevation constant times the I. You know I is a Van Hoff factor in which it depends on the compound I, meaning the total numbers of charges, something like that. For example, calcium sulfate. Calcium sulfate will dissociate into calcium plus sulfate. Okay, like that. And after that, you have to add, okay, the charge of the sulfate and the charge of the calcium. And the total will be the I, or the Van Hoff factor. Okay, so if there is a greater Van Hoff factor of that solute, calcium sulfate, sodium sulfate, like that, okay, your boiling point will also increase, something like that. Okay, so if your boiling point will increase, your vapor pressure lowers down, okay, something like that. Okay, example for boiling point elevation, delta TB. Delta TB is equal to Tf, okay, which is the boiling point elevation constant. The unit will be degrees Celsius over m, molality. Okay, sorry, times the molality. I forgot to include the molality. Times the Van Hoff factor. Okay. So 20 grams of sodium hydroxide was dissolved in 200 grams of water. Calculate the boiling point elevation delta TB. So there's no solution yet. Okay, like this in the notebook. Okay, I prepared problems I did not solve yet. Okay, so like this. Let's write this one. Okay, the problem is not too long in a boiling point elevation problem, also the freezing point depression problem. So just take note that if it is freezing point, that is depression, and if that is boiling point elevation, okay, sorry, if this is a boiling point, that's elevation. So that you can just distinguish the two. So, meaning to say elevation and depression, increase and decrease, something like that. Okay, so problem number 1. 20 grams of sodium hydroxide was dissolved in 20 grams of water. Calculate the boiling point elevation. Or delta TB. Okay. 20 grams sodium hydroxide was dissolved in 200 grams of water. Calculate the boiling point elevation or the delta TB. Our equation for the boiling point elevation to be used is delta TB KB, sorry, times molality times I. See, this is our formula for the boiling point constant, boiling point elevation constant, times the molality times the I. I is the Van Hoff factor and M is the molality in moles of solute per kilogram of solvent or water. It depends. If a clear solution, your solvent will be watery automatically. Like that. So, before going further to the freezing point depression and freeze on a boiling point elevation, the constant of water, standard temperature, it is 0.51 degrees Celsius over the small letter m for water, because we will always use this. Gosh. Because we will always use this boiling point elevation constant and freezing point depression constant in every problems regarding to this two qualitative properties, like that. So key B is equals to 0.51 like this. Boiling point elevation constant is equals to 0.51 degrees Celsius over small letter m, it is the molality. Our molality is equals to the moles of solute per kilogram of water. This is our molality, the moles of solute per kilogram of water or solute. And then later on, the value of I, or the Van Hoff factor. So, this is our I, our Van Hoff factor I. So it will refer to the dissociation charges. For example, if you have a salt, you will split up. For example, the salt involved in the aqueous solution will be sodium sulfate. So sodium plus sulfate, the charge of sodium plus the charge of sulfate plus the result will be the I. Never mind with the sign. Okay, I'll show you some examples. Okay. I so example sodium sulfate, okay, sodium positive plus SO4, so positive 1, okay, 1 plus 2 is equals to 3, like this. Okay, so I is equals to 3. Or react, okay, sulfate, then like this. This is negative 2, positive 1. Okay, so put another positive here, which goes to positive 2, negative 2 is equals to 0. Okay, so 2 sodium is equals to 3. Like this. This is how you obtain the I. Okay. The I, for example, our example here is the salt sodium sulfate. Okay, sodium positive 1. Okay, will react plus sulfate negative 2, or the polyatomic ion, right? So the product will be sodium sulfate. So we have the sodium sulfate in a solution plus water, our aqueous solution. So dissociation in a positive, okay, plus is all for negative 2. Add all the charges, okay, 1 plus negative 2 supposedly, but in getting the I or the Van Hoff factor, you will never carry the negative sign. You still have that as positive. When you add that 1, it's still positive. There's no negative values for Van Hoff factor. So you will just say 1 charge plus sodium plus 2 charges of sulfate, which is negative. Then you remove the negative sign, so 1 plus 2 is equals to 3. Or you can break that one here in our discussion like this. There are 2 charges of sulfate, and then we need to equalize that one, and our sodium is positive. And then we need to equalize that one, and our sodium is positive. So we need to add more 1 sodium positive so that it will become sodium positive 2 to react with the SO for negative 2. So it will become 0 now, charges plus 2, negative 2 is equal to 0. And then there is 1 sodium added, 1, okay, and there is also 1 originally sulfate. Okay, so once sodium added plus the original sodium is equals to 2. Okay, 1 sodium added plus the original sodium, 2 plus 1 sulfate here. So 2 plus 1 is equals to 3. So that this I is also equal to 3. Like that, huh? Especially in electrolytes or salts. Normally, for electrolysis, okay, the reaction of salt and water, something like that. Electrolytes. Okay, this is an example. Another example of salts holds true for the example. This is only one of the examples. Okay, like that. Okay. Now, our problem states that 20 grams of sodium hydroxide will dissolve in water. Okay, first we have the reaction. Okay, we need to have a chemical reaction for this. This is an aqueous solution. When we speak about aqueous solution, meaning there's water added on and no other solvent. Okay, if it is not a water, then it is not an aqueous anymore. What we mean by aqueous is always water added to a certain salt. Something like that. Okay. So we have KB, we have molality, we have the I, this one. So you can solve now the, the boiling point elevation. Okay, like that. We need to take the given. Okay, given. Okay, KB with is 0.51. Okay, delta TB or boiling point elevation is equals to KB is 0.51 degrees Celsius M times the molality, moles of solute, which is the moles of sodium hydroxide. Okay, moles of sodium hydroxide times I. So if we substitute that all, our equation will be going to be like this. Constant is equal to 0.51 degrees Celsius over N times the moles of solute per kilogram of water times the Bantoff factor, okay, for a certain electrolytes or salt. Okay, like that. In case of our problem here, here, we have 20 grams of sodium hydroxide, right? Like that. So this 20 grams of sodium hydroxide will be used in the computation of the molality. For the moles of solute, the grams of solute will be needed for the computation. Okay, and then this kilogram of water is already our numeric 20 grams. We need to convert to kilograms, something like that. Okay, so moles of sodium hydroxide first, moles of solute. Okay, like this. So 20 grams moles of solute. 20 grams of sodium hydroxide plus 16 plus 1.008. This is the molecular weight of sodium hydroxide. This equals to 1 mole. So cancel. So this is how to compute the number of moles. Okay, grams of sodium hydroxide against molecular weight. Okay, like that. So we add this 3 elements atomic mass unit. This will be our molecular weight. Okay, like that. So sodium hydroxide, so 23 something. Okay, 23, then 23 plus 16 plus 1.008. Our molecular weight for sodium hydroxide in the denominator here. Okay, so 1/40,008, and this is 20. Okay, 20 divided by 40.08. 20 divided by 0.008 is equals to 0.499 mole of sodium hydroxide. This one. mole of sodium hydroxide is equal to 0.4999. Simply do the 0.49999, or you can say that as 0.5. But to be more accurate, just use 0.4999 moles. Okay, we have the 0.4999 moles as our number of moles, moles of solute, or moles of sodium hydroxide. Now we have now the kilogram of water. We have the water is 20 grams. Convert that one. 20 grams, convert to kilogram. Okay. Cancel. So 20. 1, 2, 3. That is 0.02 kilogram water. Okay. So to make it, okay, this one is our kilogram. So 2 kilogram of water. So we have now the value of the molarity substituted to the equation, the boiling point equation. Okay, like that. Our problem, computation of I, the Van't factor. Okay, so we have sodium hydroxide dissociate into sodium positive plus hydroxide negative. So 1 plus 1 is equals to 2, I is equals to 2. Okay, this is our Van't factor. Sodium hydroxide dissociates into sodium plus hydroxide negative. So positive charge 1 plus negative charge 1. So neglect the sign, add that automatically. So 1 plus 1 is equals to 2. So in Van't factor computation or determination, we don't have to carry the negative sign always. Okay, you will just add the charges without accounting the negative sign. So that will be our Van't factor value. The Van't factor and the now obtain like this. Okay, delta TB equals to degrees Celsius over m, and then moles of sodium hydroxide is 0.49999 moles. Kilogram of water, which is 0.020 kilogram. Okay, like this. And our I is 2. This one is simply the value is m, like this. Substituting to the original equation, like this. Okay, the value of K is 0.51 degrees Celsius over m times the molality, which is equal to the moles of sodium hydroxide 0.49999. Okay, that is moles over kilogram of water. That's kilogram of water is 0.020 kilogram, and I is equal to moles of solute, moles of sodium hydroxide over a kilogram of water is simply small letter m, because that is molality. Okay, so cancel that one with the n with a boiling point elevation constant. Okay, so what will be left? So like this. So 0.499 divided by 0.02 is equals to times 0.51 is equals to times 2. So we have 25.5 degrees Celsius delta. Okay, this is this one, but this is not yet the answer because we need the solution. Okay, the temperature solvent. Okay, like that. So temperature of the solution is equals to temperature of the solvent plus temperature of the solute, or which is our sodium hydroxide. This is our equation, another equation. Because in this temperature solution, we can obtain now our elevation. Okay? Like that. So temperature solution is called temperature of the solvent, which is the water, plus the temperature of the solute, the sodium hydroxide. Now, our standard for the boiling point is 100 degrees Celsius. Okay? Things like this, it is understood to be that 100 degrees Celsius boiling point of the water, always like that. Okay? Standard for the boiling point elevation computation, 100 degrees Celsius. Okay? Like that. So, okay? So we can say also as, you can reverse it also that one, temperature of the solute or sodium hydroxide equals to the temperature of the solution, the temperature of the solvent. This one. Okay? This one. So we can say also as the temperature of the solute or sodium hydroxide is equal to the temperature of the solution minus the temperature of the solvent. Okay, now we substitute values. We know that our water is 100 degrees Celsius. Okay. So temperature of the solute or sodium hydroxide is equals to the temperature of the solution, like that. One temperature of solute, temperature of the solution minus solvent. Okay. We have the value of the temperature of the solute. Okay. Like that. So our solute is 25.5 degrees Celsius. Okay. It's here. So substitute directly. Solute 25.5 degrees Celsius. Okay. And our solvent is 100 degrees Celsius for the water. Okay. Like that. Our temperature of the solution is 25.5. So 125.3 solution is equal to 125.5 degrees Celsius. Okay, that's the one. Boiling point of solute is already calculated. So meaning to say this delta TB is the temperature of the solute. Okay? Why? Because we consider the dissociation of the solute with the sodium hydroxide, not the water. In the I, the Van factor. Okay? It's not the Van factor of the water, it's the Van factor of the sodium hydroxide. Sodium hydroxide is a solute, right? And then the molality also is referring to the solute of the species. Okay? We speak about molality. Okay? Like that. Since the boiling point elevation constant of water is equal to 0.551, since that is a solution, meaning to say it could be directly also be the boiling point constant, elevation constant of the sodium hydroxide. Something like that. So equal. So that way we will automatically use the 0.51. Okay? Like that. Actually, that is for water. Okay? That is not for sodium hydroxide. Maybe by theory, not maybe really, because that is already an ideal solution. Automatically, the boiling point constant elevation will be also the boiling point constant of the sodium hydroxide, of course. So we will just use that one. Okay? And the boiling point of the solute, delta TB. And this value will be added to the temperature of the solvent, which is 100 degrees Celsius at the boiling point, which is the water. The boiling point of water is 100 degrees Celsius. So 100 plus the temperature of the solute, we have now the temperature of the solution. Our temperature of a solution, that would mean the boiling point elevation. Meaning, we account the temperature of the solvent and the temperature of the solute. So take note, the delta TB formula, temperature of the solute, is not yet done. Okay? We still have to add that with 100 degrees Celsius, which is the temperature of the water, because we are after for the elevation. When you speak of elevation, there must be a reference point from A to B. Okay, like that. So it is a solution. Okay? There is a solute and there is a solvent. Because if you take only the solute, that's only one reference. If you take only the solvent, it's only one equals a solution. So it would be the boiling point of elevation is the temperature of the solution, not the solute. And also, you will be also wondering, because normally the boiling point elevation is always an elevation. Okay, normally the temperature will go higher. Meaning to say, it's beyond water. Okay, because the boiling point of water is already 100, by common sense, and you have also to add the boiling point of the solute. So, of course, it will be more than 100 degrees Celsius. Okay, like that. So, that is now the elevation. Okay, like that, because if you consider only the boiling point of the solute, that is not an elevation, because it is lesser than 100 degrees Celsius. So if we speak about elevation, it's a total of the temperature of the solution on the solvent, okay, plus solute. Sorry. Okay, so it's more than 100 always. Take that in your mind. And 100 should be added every time. Okay, because that is elevation. Okay, like that. Okay. Now, if you add the solute, non-volatile solute, with the sodium hydroxide, so it is understood that the boiling point elevation goes higher. Why? Because there is still the temperature. Okay, that's why it goes higher, elevated. Okay, like that. Okay, very clear. The temperature of the solvent, which is water, already 100, plus the temperature of the solute is 25.5, blah, blah, blah. It will go higher. That supports to the theory that when you add a non-volatile solute, okay, the boiling point elevation, which is the solution, temperature of the solution will increase. That's why it's called elevation. Okay, the word elevation means increase. So it's not less than 100 always. If there's a boiling point elevation problem in a certain examination, you will be asked by that in a particular problem, it's always higher than 100 degrees Celsius, or else it will defeat the purpose of the word elevation. Okay? Take that note and take that in your mind also, and it will not go lesser than 100. Okay? Every time. If the choices will always go higher. Okay? For example, if the question is multiple choice, something like that. Okay? Very clear. Now we go to the freezing point depression. So the reverse. If we have the elevation, we have the depression. Okay, it will be decreased in the addition of non-volatile solute. Okay, because of the freezing point. You know, freezing point of water. Okay, the freezing point of water is 0 degrees Celsius. What is the freezing point of water in degrees Fahrenheit? So you have to calculate, right? By using the formula 9/5 times degrees Celsius plus 32, blah, blah, blah. Okay? So it is understood that it's 0 already. A number multiplied by a 0 is equal to 0. So understood, calculating in a calculator. So 32. Okay? The freezing point of water is 32 degrees Fahrenheit. By mind calculation, since 0 degrees Celsius, it will be substituted to the equation of the Fahrenheit formula. That's why you memorize it. so that no more like that. But just to prove that you memorize it correctly, then substitute it in the formula. Okay, like that. If the question goes like this, what is the freezing point of water immediately 0 degrees Celsius or 32 degrees Fahrenheit? You'll answer. Okay, like that. It's because of the formula. Okay, like that. Because sometimes the temperature also will be given in degrees Fahrenheit, something like that. It is not in Celsius, blah blah blah, so on. So you have to convert, and you will just play around the units, something like that. Okay, and we go now to the freezing point depression. Again, upon the addition of the non-volatile solute, any kind of non-volatile solute, okay, it could be sodium chloride, sodium sulfate, like this, magnesium sulfate, sodium phosphate, like that. All are electrolytes, mainly salts, meaning there is a neutralization reaction or positive and negative charge react to the positive ion to the negative ion. That's why it will form a compound, okay, like that, known as electrolyte, okay, salts, okay, mainly if aqueous solution, okay, like that. We go to the freezing point problem, freezing point depression, okay, or freezing point lowering, okay, like that. Okay, we go now there for the freezing point. Our formula will be, our problem goes like this. Determine, okay, I'll show you in the notebook. In the notebook, there's no solution yet. Okay, upper portion, this is the freezing point depression problem, and the bottom part will be the boiling point elevation problem. I will read now. Determine the freezing point of a solution. See, it's always a solution, right? If 400 grams of aluminum chloride was dissolved in 1,600 grams of water, the Kf is 1.86 degrees Celsius M. Okay, so some textbook uses negative because it is a freezing point. Okay, like some textbook not using that one. It depends on the in the formula substitution. If it is a negative sign, then decreasing, like that. If it's a positive sign, increasing. So don't worry about that one because in somewhere along the way, okay, you can just obtain a negative result, something like that, because that is a freezing point, meaning to say negative, because freezing point, that is depression man siya. Okay, so that's negative, but don't worry, it is not given in 1.6 degrees or something like that. Okay, others giving like that, but I think normally or most of the time it is positive 1.86 degrees Celsius per molality. Okay, something, but I think I saw negative, something like that. Okay, I think only, not really proven. Okay, okay, freezing point problem, charots. Question number 2. Oh my gosh. Determine the freezing point of a solution if of aluminum chloride was dissolved in 1,600 grams of water. The Kf is 1.86 Celsius over M. Okay, take that also in your mind that the either boiling point elevation constant and point, okay, constant, freezing point depression constant, okay, it's always like that, the constant. It will never change, okay, like that, because we assume here that the temperature will remain constant, okay, like that, doesn't change. Okay, as you can notice, there's no temperature given like this at certain blah 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 so and so. Okay, maybe this not maybe, it's really proven that this boiling point elevation constant and freezing point depression constants, okay, are constant, obviously, that are constant, right? For a certain temperature, standard temperature, and I'm not sure I will be able to research that, but I think it's gonna be room temperature, okay, at 20 degrees Celsius. But because that is room temperature, the same as the basis for the water, I think so. Not really sure. Water, which is one density at 20 degrees Celsius, will be equal to 1 grams per ml. Correct me if I'm wrong, huh? Because there is also sometimes at 4 degrees Celsius, there's a density like this. There's a reference to be like that also. But what I remember only, I may be wrong also, that is at room temperature, which is 20 degrees Celsius, we can achieve 1 grams per ml of density of water. At the same time also, at 20 degrees Celsius of water, temperature of water, we can achieve also a boiling point elevation constant, which is 0.51 degrees Celsius per m molality and 1.86 degrees Celsius per m molality for the freezing point depression constant. So our basis for the temperature there is 0 degrees Celsius. Okay? And the pressure, that's very far from 20 degrees Celsius, right? Okay? And then it also looks impossible that 0 degrees Celsius. Okay? Like that. I think it's 20 degrees Celsius. Okay? 0 degrees Celsius is already the freezing point, right? The freezing point of water. So if that is the case, then why you achieve the value for the boiling point elevation? Okay? So there is already a temperature of water which is 0, the freezing point. So it's not really the 0 degrees Celsius. It's, I think, 20 degrees Celsius. Okay, room temperature, the general, basis for a calculation. I think not an STP because this is not a gas. Okay? If it is a gas, really, obeying the standard temperature and pressure, that 1 mole of an ideal gas occupies 24.414 liter, okay, in a space. Letter not ml, occupy 24.414 liter of an ideal gas. 1 mole, 1 mole of an ideal gas will occupy 24.414 liter of a gas in a space at STP. So meaning to say, at temperature 0 degrees Celsius and the 24.414, because it is understood that if the problem gives the 0 degrees Celsius, or they will just put STP, that's understood already. Okay, but if not mention the temperature, meaning it is remaining constant throughout the solution, throughout the reaction. Okay? And that would not be more relevant in this situation. Okay? Like that. It's remain constant. Just like we assume, not really assume, basis of calculation, right? Like in the osmosis and osmotic pressure, okay? We really set as the temperature remaining constant, blah blah blah, so and so. Okay, like that. No, sorry, it's not the temperature, but volume. Sorry, it's the volume that remains constant there. Okay, only here. Sorry, tao lang po. Sa osmotic pressure, volume remains temperature. I made it clear. Only here in freezing point and boiling point elevation. So it doesn't state the temperature in the problem. Gosh. Let's start at the computation or the calculation. It looks very simple, but you have to analyze something like that. What is the common problems also, or common mistakes of students Okay, even me before, okay, because we focus on the difficult problems. Okay, we focus on the difficult problems. Now, when the problem is already simple, we'll try to imagine that that's still difficult. Actually, it is not difficult anymore. Okay, due to the thinking in your mind, you will be misled and confused already what to do, even though the question is very simple or very easy to work out, because you are used to solve difficult and complicated problems in that particular topic. Okay, especially in a college, you will go to the more complicated one, not on the simple and basic one. And then in the examination, let's say PRC board examination, they will just give not really that difficult, only average like that. But the students thinking are already difficult, something like that. Okay, it's only the mind of the students, because what we believe something like that is this is an examination, this is very difficult. Sometimes we need that what do you call this one, psychology. Okay, it's not like that, it's not really regulate. There will be no more engineers in our country. If that is the case, they will give all difficult problems. Just try to think about that. Of course, they will normally give above 50% not difficult. Okay, for example, and they will just give difficult, which is 30%. Okay, because they are regulating. That's why it's called Philippine Regulating Commission. Philippine Regulation Commission, where they are regulating how many engineers will pass, okay, according to the needs of different industries existing in the Philippines. That's because if there's no regulation, so many will graduate, and then there's no calibration. We cannot gauge, okay, the applicants or whatever, like that, blah blah blah, so and so, okay, and then due to the registration, something like this, because there are engineers that can sign document papers, something like, for example, mechanical engineer can sign a document, architect can sign a document, and they cannot proceed the project without those signatures. The civil engineer will sign also. Okay, but it's very essential for their career. And the accountancy also, accountant can sign certain confidential document, but the not accountant, he cannot sign like this. That's why they regulate it, something like that. Okay, for the registration. Okay, okay, so that's why don't be afraid, something like that. Okay, so it looks like difficult is very easy to solve. Okay, problems like this. Okay, 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 freezing point. Okay, we have delta. So in short, if we have this delta TF and delta TB, that would mean technically the freezing point of solute. It's not yet the solution. Okay? It's very clear, huh? Because we still have to incorporate the value of the freezing point and the value of the boiling point after getting when we found out the boiling point elevation and the freezing point, okay, depression. Okay, that's why it's still needed, because others also will stop here. If we can get the delta TF, that's automatically our elevation. It's not good. Okay, delta TF from the boiling point. That's the purpose. Okay, TF. Okay, times the molality. Still the same, molality. Okay, times the I. Actually, also, the problem also sometimes will confuse you, because the molarity, of course, they can give the density, okay, at that particular solvent, so that they can compute for the mass, like that. Because we have the kilogram as the numerator of our, and since for the water, our density is standard, not standard at 20 degrees Celsius, I think so, it should always be 1 grams per ml. Okay, so you can have now a kilogram of water. What I mean is, if it is no longer a molality given in the problem, you can convert the molarity to molality. Okay, like that. If also the molarity, then convert to molarity. But the problem is if it is given in normality, what? So if given in normality, that is equivalent to weight of solute over the liters of solution, right? Then get the gram equivalent of solute by considering the number of moles, like that, blah blah blah, and the molecular weight. Okay, actually these are three: molarity, and normality. Okay, so I think for me the most difficult is the normality, because there's a confusion how to compute the equivalent to weight, and you can get it weight. Okay, molecular weight. In order to get the equivalent to weight, the symbols for that is EWT, all are small letters. EWT, equivalent to weight. Charot. Ganun talaga. Molecular weight divided by the basicity of the acid. Okay? Or divided by the acidity of the base. So it depends if you get the hydroxide, okay, if you get the H ions, or the, like that. It depends. Or we can say already the molecular weight divided by replaceable, meaning the one who will transfer to another side, like this. Okay, I will show you later. The molarity, okay, now you can only solve normality directly also, okay, like that, by multiplying. Charot. Okay, get the molarity, something like that. Okay, it's gonna be like that when you get the normality. Okay, like that. You will times only for the how much, the blah blah blah, so and so, the replaceable H. Okay, like that for normality. Okay, like that. Okay, so normality, okay, is equals to molarity times N. I will show you normality, sorry, capital N is equals to molarity times N. Now, we are used to that the N here, this equation. We are used to that the N is the number of moles, but in this case, in the computations for the normality, the N stands for the replaceable H ion, or the OH negative ion, H plus ion, okay, and the H negative ion. Okay, so if we mean about ion, ion, that means it could either be positive and negative. Okay, it could be a positive ion and a negative ion. So the positive ion will be the H, chloride, sulfate, like that. Okay, the polyatomic ion, the polyatomic ion is the negative ion. Now in this N, okay, in this N you have to have the replaceable OH like this. Okay, replaceable OH and replaceable H. Okay, like that. Because it's not I. The Van top is the total, right? The total of all the... Sometimes it will confuse you. The Van top factor is the total charges you have to add, or total ions you have to add, right? And then this N is not like that. It's only the replaceable H, replaceable H, something like that. Okay. Okay, correct me if I'm wrong. Okay, this one, like this, small letter N. Okay, but never mind, we will never use that one here because there's no normality here. I'm talking only for if the problem states the normality, something like that, or states the equivalent to it in the problem. Okay, or it will just confuse you to make it difficult because they measure the learning outcome of the student if they really understand. Okay, something like that. That's why they make it substitute with another variable. Okay, like this. because that would mean that they understand, even though they will put another variable through correlating the different formulas. Okay, like that. Okay, very clear na siya. Okay. So for example pala, if normality, and then you look at, if you try to calculate the normality, so if you have the molarity, you can multiply directly that with the n. Okay, that's your normality. Something like that. Okay? So, key F, 1.86, it was mentioned. Okay? Over n. Molality, we don't need to give the units one by one because it's already m, right? Like that. So just put m. Anyway, it's understood that it's mole solute per kilogram of solvent, right? Okay. And then we have the grams, 400 grams of aluminum chloride. We need to compute first the moles of solute through the mass of aluminum chloride, which is given in the problem, something like that. Okay. So compute for the moles of solute. Number 1, moles of aluminum chloride. Aluminum chloride is an electrolyte because chloride is negative, or it's the salt. Okay? Electrolyte. Okay, moles. We have the 400 grams of aluminum chloride times the molecular weight of aluminum. Okay, that is 26.98. I already memorized the common one, that's why. So the atomic weight of aluminum is 26.98. It's 26.98. Okay? And for the chlorine also is 34.45. My gosh. Ganon? 34.45 or 35.45. So if you are in doubt now, you have to refer to, for the handbook, like this. Okay, but 34.45 also is very near to 35.45, right? But I think it is 34.45. So let's just prove it, okay? Later on. Later on talaga. 35.45. I think 35.45, okay? Okay, i-times mo to 70 ba siya? Okay, i-times ba mo ang 2 times 35.45. Okay, 45, no, 32 times 35, 2 times 35.45. 70.9 liya siya. Whereas, kung 34.45 the subscript of the chlorine gas, something like that. If you forgot, okay, 20 plus molecular weight of the chlorine gas has the molecular weight of, or atomic weight, right? Because it's a single. That's not a compound. Okay, atomic weight. The chlorine gas has an atomic weight of 70.9. Okay, and now you memorize. You forgot what is the ANU of chlorine. It could either be 35.45 or 30. The thing to do is you have to prove that since you know the atomic weight of chlorine gas is equal to 70.9. So if you multiply the one you memorize equal to that atomic weight chlorine gas. So that is the correct. Okay? So based on my computation, the 35.45 really is the atomic weight of the chlorine or the AMU, atomic mass unit. Okay? Like that. It's not 34.45, it's 35.45 because chlorine gas has an atomic weight of 70.9. If you multiply 35.45 by 2, the answer is 70.9. So you really prove that you have the correct atomic weight of chlorine. Chlorine only existing as chlorine, not chlorine gas. Okay? It's different because it's only chlorine, and chlorine gas has 2 subscript and the chlorine has no 2 subscript. Okay, meaning you are referring only the chloride, something like that. Okay, and then Cl2 you're referring the gas already. Okay, so there's a difference. Okay, like this. So here the chlorine have the 3 subscripts times 3. Okay, like that. And then we have 1 mole of aluminum chloride. Okay, cancel the grams of aluminum chloride. You have now the moles. Okay, pila man siya. Fairness. Charot. Okay. So, 400 grams molecular weight 35.45 times 3 plus 26.98. That is 133.33. That is the molecular weight of aluminum chloride. 3 grams. So there are 133.33 grams of aluminum chloride in 1 mole of aluminum chloride. That's why it's automatic. That is the molar mass. Okay, because you consider the moles upon your determination of your mass, which is gram. That's why it is called a molar mass. Okay, because your reference is the moles. Okay, it's derived there. Okay, so you divide them here. Okay, 400 divided by 133.33. So we have 3. My gosh. 400 divided by 133.33. So you have another 3 moles of aluminum chloride. Okay, 3 and a kilogram of solvent. So how much is our water here? We have 1,600 grams. So that is in grams. So you have to you have to convert it to kilograms. Move the 0. Something like that. So okay. So 1.6 like this. Times the I. Ito na naman siya. Ang I na ang Van Hoffman factor. Okay. Van Hoffman factor. Pila man siya. So we have the aluminum chloride dissociation. Charot. Ganun. Dissociation. My gosh. Okay. Aluminum with a positive free charge because this is in the group 3. Okay. The charges is also in the possession of the periodic table. For example, if we have positive 1 charge, that is belong to the group 1 family. Something like that. If this is a positive 2 charge, that is in a group 2. Like this. Positive 3, group 3, like that, blah, 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 so and so. Okay? Now we have the last one. So there's no charge at all. I think so. Okay? The krypton, the xenon, the argon, right? I think they have a charge of 0. I'm not sure. Because those inert gases, which is the last, the krypton, the xenon, the argon, right? I think they have a charge of 0. I'm not sure. Because those inert gases, which is the last part of the column of the periodic table, are those stable, meaning they will never react anymore to other elements and compounds. That's what they call the inert gases or the noble gases. Okay? Another term for inert gas is the noble gas, meaning to say non-reactive to other element and non-reactive to other compound or non-reactive to other substances because themselves alone are stable. It's very clear, huh? Sometimes it will come out to the word krypton plus like this, and it will produce a product. They will krypton, sulfate, and they will just try to test the student like that. And A like this, krypton sulfate, B like this. And the choices are, it looks like logical, but then in letter D, none of the above. Something like that. And you will answer none of the above because krypton will not react to any other element or compound. So by theory alone. Then if you follow the type of chemical reactions, they were double displacement, right? So when you have the double displacement, it could have like that also. Okay? Krypton sulfate like this, xenon sulfate during the double displacement, okay, or replacement reaction. But by theory alone, it will never react. So deceive the student or the examinee. They will confuse, trick the student. Okay, like that, to think deeply, to retain the basic concept and basic theory, something like that. Okay, so aluminum chloride. Okay, aluminum chloride is this. Okay, this one. My gosh. Okay, splitting that one to the dissociation process with aluminum positive 3, because this is in group 3, something like this, plus 3, and then chloride, it is in like this, and this is 3 is a subscript, like this. But take note, okay, this is also deceive the students like this, huh? Because this is a rule in a redox. Okay, see, we'll try to connect also. This is another topic, right? This is a colligative property, but sometimes you don't have to forget the other concept also by the redox equation, the equilibria solution, okay, the solubility product constant, something like that. There, in the dissociation of gases, like this, blah blah blah. See, like this. You will never say Cl3, because when you split the chlorine, it is always chlorine gas. Remember that one. It's always chlorine gas will produce if you split the aluminum chloride. Let's say, for example, if you do the by application of the heat or exothermic reaction normally, like this, or a pyrolysis. Okay, the applying of temperature, let's say above 1000 degrees Celsius, like that. Pyrolysis, meaning very high temperature, extreme high temperature, enough to split the compound aluminum. It's not Cl3. So this is a wrong dissociation. You should put that in another manner, which is chlorine gas. Oh, diba? Chlorine gas. So we're like this, aluminum positive 3 gas. Okay, this one. Okay, like this. And balance, like this. You need to balance. Okay, like this. Since this is negative, the charge of chlorine, or the chloride negative, writing of molecular formula. So aluminum is positive 3, okay? And we have negative 1 chloride. So how many Cl2 you need? You still need 2 more Cl2 to neutralize the aluminum positive 3. So that when you add the charges positive 3 to the negative 3, which is Cl2 multiplied by itself into 3 times, you will get negative 3. Positive 3 plus negative 3 is equals to 0. Okay? So, you need to add where is the side which is deficient. Here, the deficient is the chlorine because it's only negative 1. So, you need to add 2 more chlorine gas. Something like that. Okay? Now, okay. Actually, I just analyzed something like that, okay? This is not really the explanation on the, on the YouTube, whatever. I just analyzed in my own, something like this, okay? Because if you understand, you can analyze by your own also, even though there's an explanation for that. For example, in the Google, in the textbooks, or in the, let's say YouTube, there's an explanation there. Okay, it may differ also in your explanation, something like that. If you really know what's working behind on those topics, something like that, if you really understand really the basic concept. Okay? Now, what will happen if I put like this? So this is kind of proving in my own. Okay? The first, I dissociate the aluminum and Cl3. Now, Cl3 is non-existent in the universe or in the earth. So this is an illogical reaction. It will never exist at Cl3. It's always Cl2, right? Now I change to aluminum positive 3 plus chlorine gas. Okay? Now, I make it balanced in order it will react with each other so that their charges will become zero in order to make a compound, right? That's a basic theory in order to become a compound. Now, they will never react here because this is a chlorine gas. Okay? This is a chlorine gas. So it should be chloride. Okay? It should not be chlorine gas. Aluminum positive 3 plus chloride. Okay? Wait. So this is the third trial. I just proved the theory during the dissociation. This is actual, aluminum chloride. I'm just trying to explain why you will never use this one because there's a 3 here. Okay, if you are a student that's on the average, like me, we'll always use the 3 in the splitting. No, it's not. Okay, so aluminum positive 3 plus chloride. Okay, negative 1. So in this case, you will never put 2 anymore. Though, it will always have Cl2 in the reaction. You know why? Because this is only dissociation. This is only dissociation, meaning this is not only. Okay, you split only the component into their charge. That's also the second proof. Okay, chlorine gas is a gas, of course, diatomic gas. Ion or charge, negatively charged particle, and that is also considered as polyatomic ion. Something like that. Under the polyatomic ion, something like that. Because there's no term as monoatomic ion. It's always aluminum chloride, aluminum positive 3 plus chloride, Cl negative 1. Now, what will happen to the 3? Your 3 will be put on the side to the chlorine. Like this. See? So, aluminum positive 3 plus 3 chloride. Something like that. Okay? Like that. So, now you have chlorine negative 1 and aluminum positive 3. So, you need two more chlorides, not 2 more chlorine gas, really. See? You don't need 2 more chlorine gas, but 2 chlorides to compensate chlorides, which is negative 3. Okay? We need to add more chlorides here. So, chlorides plus chlorides. Okay, like this. So, charge of aluminum positive 3 and negative 3 is equals to 0. Something like that. 0 na. No. How many chlorides? There are 3 already because you add 2. So, 1, 2, 3. So, put chloride and then close and open parenthesis 3. ElCl3 or the same as ElCl3. Now, the analysis. See? We have AlCl3. So this is the correct dissociation. It is the aluminum positive 3 plus chloride negative 1 times the subscript 3 besides the chloride. Negative 1 it will never hold because the chloride is not equal to chlorine gas. Okay? And then aluminum positive is not also Cl3 because Cl3 is not existent. Only ozone. You know ozone? Most of oxygen. Chlorine is never be like that. There's no such Cl3 occurring in the atmosphere. That also. Or it will be. Ba yan? Okay? So, aluminum proven to be correct na ha. This is our dissociation. 3 plus 3. Okay? Okay? As we can remember, number of atoms is equal to the coefficient times the subscript. Now, if the subscript is 1 or no stating is automatically 1. So 1 times 3, that is our atom. That's why I spoke to you 3 atoms of chloride. Not this. It's confusing between most and atom sometimes. Most of the students will they use that interchangeably, but the number of atoms is not equal to the number of atoms. Okay? Because the number of atoms always use the concept of Avogadro. You know Avogadro constant, or the number which is 6.023 times 10 to the 23. Like that. Okay? Ions or molecules. Depends on the calculation what they wanted. As long as there's 6.023 times 10 to the 23, it could be an ions, it could be a molecules, it could never be a mole. Okay? Like that. So, because in the law of conservation of energy, law of conservation of mass, it's also stated that the total mass okay, of the left is equal to the total mass of the right, or equals of the right. Law of conservation must does not state that total number of moles in the reactant is equal to the total number of moles in the product. It's always the total number of atoms is on the reactant is equal to the total number of atoms in the product. Okay, so there's a difference for that. Okay, meaning if you add all the number of moles, it will never equal to the number of moles of the product and the reactant. But if you add the atoms from the left or the right or the reactant or product, it's always equal. That's why we need to balance that chemical equation. That's the purpose. We need to balance the chemical equation to meet the law of conservation of mass. That's why we need to understand. Okay, why we should balance this one? Because we need to follow and obey the law of conservation of mass, or else it will never be now a law of conservation of mass. So that is no longer a steady state equation. Okay? You do the balance equation for something have a beneficial purpose. Okay? It has a purpose for that. Okay? It's not only that we need to balance the left and right. No, it's not. We need to do that to obey the law of conservation of mass. Okay, in relation to the law of conservation of energy as the basis of chemistry, something like that. Okay, now we have this. Too much explanation, and we are only getting the Van Hoff factor I. Okay, okay, the Van Hoff factor I. How many? Okay, you have the chloride -1 plus +3. Okay, this is 4. Because as I told you before, the negative sign will not matter. Okay? Because you are talking of ions. Okay? Mainly it's an ions only. And ions, it could be negative or positive. Just add the 2. 3 plus -1. This one, algebra will not hold through. Because in algebra, you will consider the sign, right? If you add +3 and -1, it is +2. But here, in a Van Hoff factor, +3 charge plus -1 charge is always equal to +4, because your sign is hypothetical, irrelevant, or insignificant. Okay? Irrelevant, insignificant, doesn't have the substance at all of your sign. So that is equals to 4. Okay? Like this. Here. Okay? Without splitting also. You can still do that also. So chlorine have 3 right here in the original formula. And here also, okay, like that. And that will hold through if there's no coefficient. Because if, for example, 2 moles of aluminum chloride, your I will not be 4 anymore because there's a subscript. Oh no, coefficient. Good for here because there's no coefficient. You can add immediately the 2 here plus 1 here. So, or the 3 here of the chlorine plus aluminum. Okay? In the compound, because it is already a compound, you will never say chloride anymore. Okay? It's chlorine already. You understand? If you have the aluminum chloride, that's the naming. Okay? And then if you try to name it one by one, it is aluminum and chlorine. It's not chloride anymore because there's no charges anymore. They're already reacting with each other as a stable compound, aluminum chloride. Now, if it will produce Cl2, you also speak chlorine gas, not chloride or not chlorine. So, meaning to say, chlorine can exist in a 3 form. It could be the chloride, it could be a chlorine itself, it could be a chlorine gas. Now, you must understand the application of these 3 when. Okay? When chlorine gas, meaning to say, you dissociate that into the product, will produce, this aluminum chloride will produce normally chlorine gas. So that's the time you will use chlorine gas. Okay. Now, if you use the chloride, that's the time you only dissociate this one as what I explained to you a while ago. Aluminum positive 3 plus chloride. So that's the time you will use the term chloride. You will state it individually. What is the total atoms? Blah, blah, blah. What is the total atoms in the left? What's the atom? You will never say, what is the total atoms of chloride? No, it's wrong grammar or technically incorrect. It should be the total number of atoms of chlorine. And it's not also, what is the total number of atoms of chlorine gas? No, it's not. Because we are naming individually, you should not carry the product appearance or the situation, what's we call it in chemistry? Form. Okay? Form. Like that. Okay? So, be careful. Something. If you understand that one, then there's a possibility that, you will pass the physical and chemical separation processes of subjects. Something like that. Possibility only, because not all will pass also. Okay? Like that. So we have the 4. So 1, okay? 1 plus 3 is equals to 4. So the I will be the same. I. So now, we will substitute that here. It took a longer time to explain the I, the Van 't Hoff factor. Okay? So sometimes like this, in an examination, question number 1, what is the Van 't Hoff factor of aluminum chloride? On as simple as that only. Okay, and you have to use the theory. Okay, this is the 1, blah blah blah, so and so. Okay, like that. Okay. So I is 4. Goodness. Okay. Multiply that 1. 3. In the algebra, we will obey the PEMDAS. Okay. Parenthesis first, second will be the exponential, the third will be the multiplication, the division, addition, and subtraction. Because this involves bracket already, right? Maybe we will be tempted to do the other operation, the bracket first. Okay? Because it will change also the value if you will, you go to the subtraction first or the addition first. This is a rule, always the bracket and the open and close parentheses first. Okay? And then second will be the order, the roots, the exponential, or let us say the indices, exponential. And the third will be the multiplication, the fourth will be the division, the fifth will be the addition, and the last operation to be considered is the subtraction. Okay? PEMDAS, or you can say that as a POMDAS, meaning bracket, okay, like that, and then order meaning the roots, the exponential, like blah blah blah, so on, so is to the power blah, blah. And then BOMDAS, multiplication, division, addition, subtraction, something like that. Okay, it's the same, only the acronym changing. Okay, so 3, my gosh, 3 divided by 1.6 is equals to times 4 is equals to times 1.86. We have 13.95 delta TF. So meaning to say we have the freezing point of the solute yet. Okay, delta TF is equals to 13.95. Okay, like that. Okay. Now we use the same principle for the boiling point elevation. Okay. So freezing point tayo, di ba? So freezing point depression. Okay, which is depression T solution, right? TF solution, because F indicates freezing. So TF solution, supposedly, let's just try this one, the same as a theory with the boiling point elevation. Okay, we will analyze it. So temperature of the solvent plus, supposedly, this is the general equation, right? Plus the temperature of the solute or the aluminum chloride, which is 13.95 delta TF. Okay? Okay? Like that. Okay? Like that. Now, you will get the temperature of the solution. So what is the freezing point of water? the freezing point of water is 0 degrees Celsius. Okay, like that. Reduction, minimization, or reducing, like that, right? Correct me if I'm wrong. Okay, reduction, minimization, lowering. There's a lot of terminologies applied for that in English. Okay, so the freezing point is 0 degrees Celsius. Okay, so plus 13.95. Let's just do it. Okay, like this. Okay, this ones, it is correct or not? Temperature of the solution is equal to the temperature of the solvent plus 13.25, and we know that temperature of the solvent water at freezing point is 0 degrees Celsius, like this. The freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit. Okay, and then you know your formula is depression. What you will do for this? Depression meaning minus rho. Okay, because we have depression. So meaning you have to subtract the freezing point to the value which is 13.95. So this is 0 minus 13.95 because that is depression. So meaning to say, it always have the negative temperature. Okay? Because that is depression. Okay? So 0 degrees Celsius, even though we have the fury, which is the same as the boiling point, it will be deviated. Okay? Because we know that depression is subtraction and lesser, deducting. And then you know also by fury that always less than 0. Okay? Our freezing point. Okay? It should be always be negative. Okay? Because the freezing point of water is always higher to the solute. Okay? Like that. Because 0 degrees Celsius is positive. Okay? Though it is not a number, but it is positive. Okay? And it's always higher than negative values. Okay? Like that. So, meaning to say, the freezing point of water is always higher compared to the freezing point of the solute. Okay, like that. So therefore, I conclude that the freezing point depression is always, okay, lesser than the solute. Understand now? Because we get already the freezing point of solute, which is 13.95, like that. And by theory, if you add a non-volatile solute, your freezing point of solution, depression, will always be lesser. Okay? So it's not 13.95 already. It's always negative. Okay? Like that. Because of the principle of the freezing point. So 0 degrees Celsius minus 13 degrees, it will be like this. Negative 13.95 degrees Celsius. Okay, so our freezing point 10.95. This one. Because depression. Okay, the word depression meaning deducting, reduction, minimization, lessen, L-E-S-S-E-N, dwindling, D-W-N, only English terminologies. Okay, like this. Okay. Depreciate, it could be. Lowering, it could be also, because that is also, diminishing, it could be also another terms for depression. Okay, like that. Negative, always negative. So meaning to say, the freezing point of the solution or the freezing point depression is always lesser to the freezing point of the solute. Okay. Our solute is aluminum chloride because of this principle. By theory. You have the theory, okay, and you can prove that through the calculation theory. Wrong with your calculation. It never be the theory will be wrong. It's always the calculation will be wrong because the theory. For example, I will try an example like this. Boils low, something like that. Okay. The constant is the temperature. Okay. So P1, V1 is equals to P2, V2. Okay. And then out resolution, you use the temperature. Okay. So you did it now the theory. The same here also. If you have an answer positive, you did the theory already. Because you will be tempted to use temperature of the solution plus temperature of the solvent plus temperature of the solute. But remember, this is depression. And this is always lesser than the freezing point of the solution to the freezing point of the solute. Something like that. Okay? Like that. Again, this non-volatile solute is always basically the electrolytes or the salts. Okay, in freezing point depression, it's always decreased upon the addition of non-volatile solute, something like that. Okay, and the freezing point or the depression, the freezing point depression, because it is depression by the term alone. Okay, like that. Okay. So sorry. Here, sorry, I'll just remember by theory only. See, by theory will matter really, right? Every time you have the calculation and you have to prove it, and then if the theory doesn't satisfy your calculation, you will try to force to review your calculation. Maybe somewhere along the way you are in error, something like that. Just like in aluminum chloride, right? You try to dissociate this one, it's correct. Okay, meaning to say, I am discussing to you in actual. Okay, not prepared or not scripted, not prepared, because if I do this scripted and prepared, it will never go this far. I will go directly to the aluminum positive 3 equals 3 chloride negative. Then why I try so many something like that? Because there's an option. This is on the spot. Okay, like that. There's a difference between you prepared what you've logged. Okay, or you already solved what you've logged, or you just do on the spot what you've logged. Okay, it doesn't prepare. As you can see in my notebook, there's no solution yet. Okay, that's why you're wondering my blog 1 hour 50 minutes, because that is not scripted and that's not prepared. I don't go directly to the direct solution that's gonna be correct like this. So meaning to say you are perfect, right? So it's really confusing. You are really perfect. Maybe you prepared a lot. Of course, you are prepared a lot. Okay, but here I do it in a trial error method, and then we come up to the validity by proving the theory and the equations and the solutions basing on the answers. Okay, like that. Here, that would be very important. Atomic gas. There's no I3. It's always I2, F2, Cl2, CO2, O2, except for ozone, which is O3. Okay? And then if you put this Cl3 in the aluminum chloride dissociation, you will become wrong. Okay? Because that's why I interpreted first. Okay, but then I will recall the theory, it's wrong. Something like that. So theory and concept is very important. Even though you will not go to the deeper problem solving, if you have the basic, then you can really understand the complicated one. Okay, so meaning to say, if you are really a professor and instruct the topic first before going to the difficult one, it's really wrong, because the students will be confused if there's a very difficult problem, and they will just follow the pattern how it is being solved. Okay, of the theory. Okay, and they will understand really, even if it is a difficult problem solving. So we have the basic, okay, like that. Okay, so for me lang, okay, because I'm not really a professor by in real. For me, it's better that the instructor and professor should be like that. They should discuss. Okay, that's why there are also some instructors who will give the basic one and the issue one, and then in the examination very difficult they will give, because they think that the students understand also. Like that. Okay? But I think most of the intelligent professors and instructors will do that. Okay, they will be happy if they will give a very difficult examples. Reverse to the instructors and professors, because they will try to level their minds to the students. They will not think they are above IQ, or they will not think that they are more than the students' level of understanding. They will try to equalize their level of understanding to the students. That's why they do in a very systematic discussion compared to the very intelligent instructor and professor, because they think their level of understanding is already high and they try to equal to the students, but it's not never equal to their level of understanding. So that's the barrier. Okay, that's why most of the students can understand well if the professor is an average, not the very intelligent one. Okay, because their minds are very fast, very quick, higher IQ, but the students it's not higher IQ. You cannot expect that what you discuss will be tried to understand immediately by the students. Okay, and you expect them to understand because your mind is higher than them. It's not like that. Okay, so I'm talking generally. Though there are also intelligent that we discussed in a detailed manner. I'm talking general. Okay, like that. What do you call this one? Majority, but not all, or some, or a few specific statements. Okay, like this. Okay, thank you so much. Okay, just bear in mind that the freezing point deflation is always negative because elevation. Elevate, enhance, augmented, increase, okay, intensify. Okay, okay. That's why if you are good in English also, it will help in the comprehension of the problem solving. Okay, because there are terms that they will try to confuse the students by using another term. Concentration. Concentration is the same as solubility. Okay, like that. So because they are used to the solubility colligative property. Example only. It's still applicable. Okay, because solubility could either be a molality. Okay, a molarity and normality. It's all about concentration. Okay, again, solubility, it could either be molality, and normality. Okay, now if the Henry's law problem also state that as a molality, solve that as is, because that is also solubility. Do not depend because the word discussed by your instructor is solubility, and then you'll never apply that problem anymore because there's no solubility term like this. Okay, it's just the same. There's just what do you call it? Trick, T-R-I-C-K. Okay, they're just trying to trick you out to fall in the trap. Okay, like that. And then if you did not think very well, and you will fall in the trap, something like that. That's why synonymous terms are very important also. Vocabulary is very important also. Okay, synonymous, antonyms, synonyms, homonyms, like that. Okay, very important also. It can be related also to the sciences, mathematics, anything. Okay, that's why for me, the most important subjects we have is science, English, and mathematics. Only 3. Okay? Without other subjects, you can survive. Only 3. English, science, and mathematics. Okay? Very clear, huh? Okay. Like that. Okay, any questions so far? If you think that my live streaming is very substantial to you guys, then please comment, like, and subscribe. Then if you want that this very important live streaming of mine, then you can share it to the other people also, then share it, right? Okay. And then if you want also, click notification bell. Live streams and vlogs in the next day, in the coming weeks, and in the coming months also. Okay, like that. So, since I promised a while ago that I'm not going to solve about chemistry, but it runs out of time because there's a lot of coverage of chemistry also. I'm not yet finished. There's a lot. The redox, the oxidation, blah blah blah. Okay, equilibrium. You know equilibrium? Equilibria, something like that. Nuclear chemistry. You know nuclear chemistry? The protons, the electrons, the positrons. Okay, the radioactivity, the reaction of the radioactivity, alpha, beta, gamma ray. How to compute that one? Okay, like that. That is radioactivity. That could determine how radioactive elements and compounds are. So you need to know the reaction of the alpha particle, beta particle, and the gamma particle, or the X-ray, something like that. Radiation, talking about radiation. Okay, radioactivity, something like that. Okay, involves radioactive materials. Okay. And in there also it's very important to know the half-life of the certain elements. It will decay after how many years, like that. What will be left during 10 years, 5 years, like that, okay? And it's in there also that's being discussed, the isotopes. You know isotopes? If we have isomers in the organic chemistry, we have also isotopes in the nuclear chemistry. Okay? I think it is atoms with the same atomic number or number of protons, but the same in different in their mass number. Again, isotopes are those elements that have the same number of protons or the same atomic number, okay, but differ in their mass number. I'm not really sure, but that's what I left in my brain 20 years ago. Okay, I'm not really sure. The only way to prove it is to research for yourself if I'm talking right or correct. That's why I'm always telling you, correct me if I'm wrong, correct me if I'm wrong, like that, because I'm going to issue an error statement in my vloggings and my live streamings, because there's no such perfection. Okay, all will commit mistakes. No. So by the way, tomorrow talaga, I will be able to solve some of the physics problems regarding the motion only, the projectile. You know projectile? Throwing a ball, a baseball, like that. What is the velocity? Okay, after hitting to the ground, the initial velocity, the final velocity, the acceleration due to gravity, something like that. Okay, motion. V final, V initial, acceleration initial, acceleration final, blah blah blah, so and so. At a certain point, they will meet, of course. So their time will be equal, right? And when they meet with each other, the time will be equal, right? Of course, and we will solve for the distance, the velocity, the acceleration, blah blah blah, so and forth, so and so, and then the free falling body also, as what I remember, that is in physics, I think. So that is height is equals to, based on what I remember, height is equal to, very difficult really, if you try to remember something you had memorized 20 years ago. Height is equals to gravity. Wait. Oh my gosh. It's minus, really. You have to minus the gravity, because that's falling, right? If that is falling downward, you have to minus, right? The negative sign. Just like in the depression and the lowering, right? Negative. So it's gonna be height is equals to the velocity, or the times the time, minus oh my gosh, 9.81. Oh, 1/2, because it is half of the 1/2 times 9.81 times t raised to the power 2. Correct me if I'm wrong. This is gonna be like that, okay? Okay. There's a final this time. Actually, it is the velocity. It's already negative because that's an acceleration going downward. Okay, especially, for example, if I was dropping a ball on a cliff, okay, of course, there's a negative sign for that because that's going downward by Fury. So you will be no longer stating that one as total velocity is equals to the velocity total is equals to velocity final minus velocity initial. Because downward, it's not like that. Distance is only a horizontal. Good if the problem will stay high. You know height? Because height is vertical. Okay? If height is vertical, you consider negative sign, right? Because it is height. Okay? But if it is distant horizontal, you will not cover negative. It's always positive. So if you're talking about height, so it should be the height covered B minus the height covered A, but the going downward, okay, and the acceleration to gravity will be applied. So that's why height is equals to velocity times time minus with the going downward situation talaga, minus 1 half times 9.8 times t raised to the power 2, something like that. Okay, for computing for the height in throwing a ball, dropping a stone on a cliff, so that will be your formula. Okay, negative. This should be negative. Okay, it decelerate. The word deceleration. Okay, decelerate means negative. Okay, like that, or going very slow. So meaning, so that's why memory, the power of the memory plus analysis. Analysis meaning how you plus, if you can, plus theory, the who blah blah, what is the value blah blah blah, arithmetic mean, like that. Theory, okay, you cannot guess, it's a theory. Then you memorize. Arithmetic meaning you have to add only. So x1 plus x2, meaning averaging, just like a computation of the grade of the students. Averaging, you can get 88%. You have so Lipunan, Filipino, science. If you add that all how many, and that is your mean, arithmetic. Okay, our averaging. So in the geometric mean, that would give the formula arithmetic mean. That's theory, that's not calculation. Okay, so the memory plus the analysis and the comprehension, and plus the preparation, something like that. So only 3: mental state of mind, the health, that could be also a faculty secondary, okay, like this. But I think prayer is number 1 for me, only for me. Okay, it could be because there are people who are practical, right? They are very, very practical. Okay, so they will not consider God also as number 1 in their preparation. Okay, but for me, God number 1, prayer, plus the power of the memory, plus the analysis and comprehension, plus the adequate preparation. So meaning to say, if you have the adequate preparation, you have to cut your activities. Okay, suffering your other activities in preparation of that particular examination. For example, if you are really love to go to the party, then you have to stop it. If you love to go to your friends, and you know the examination is 3 months coming, after 4 months, then that 4 months you'll be devoted only for studying. Okay, something like that. And then if you really love to watch teleseries in the TV station, then you have to cut it off. Okay, like that. You don't have to do it anymore. You have to discipline yourself. In order you can have an adequate preparation, and then you can no longer do the things in which you do most of the times, in which that is not related for your study. So that is part of adequate preparation. Okay, like that. So where does the buying of the resources involve? May ganon. Okay, buying or going to the library, okay, for prior to the examination, or scanning different books, reading, like it's part also for the adequate preparation. For example, you will buy reviewer's book. Okay, that's part of adequate preparation, or the resources is under for the adequate preparation. Okay, but the power of memorization is another thing, and the analysis and comprehension of the coverage of the subject. Okay, like that. Because even though how many adequate preparation you have, for example, you prepare for 1 year, for 2 years prior for examination, but you don't make, but your comprehension is not really that good enough, then even though how you prepare too much, it will never also be successful. Okay, like that. So you should have the power of the memory plus the comprehension analysis as adequate preparation. In the adequate preparation also, it involves the practice also, especially in the problem solving. Okay, so before practice, of course, you will memorize the formula. That is part of the power of the memory. Okay, that's only my formula. My formulas in passing the examination will be prayers, okay, intelligence quotient, something like that, and plus the analysis and the comprehension, number of adequate preparation. Okay, the practice makes the adequate preparation, the resources initiative is part also of adequate preparation, something like that. Okay, then for me, there's no reason to fail if you follow that one. But If the God will not give it to you, you will never pass also, even though how hard you try. That's why I'm telling you, number one is prayer. You have you like that. Yeah, he's the one for you, something like that. But you only do that because God is pushing you to do something also in order for you to pass. Then if you are just praying and praying, you will never do something, then you will never pass also. Okay? Something like that. And the one, the faith, F-A-T-E, and the luck, L-U-C-K. But that's not really that higher percentage. Okay? It's not really that higher percentage for me. Variety something for me it doesn't really contribute to pass or to faith. Okay? But there's still a percent, 15%, that's your luck, something like that. Luck meaning through guessing, you don't know the answer, questions, okay, multiple choice questions like this, blah blah blah, so on. Okay, thank you so much. Oh my God. Thank you for this live streaming, and thank you so much, Lord. We thank God above all things that we finished discussing properties. I hope, guys, you will never forget this one, though this will not be applicable in our daily lives because we are not in the actual or reality, but we still have the basic concepts to be able to be used in our daily survival in this contemporary world, something like that. Okay, the basic one. Okay, especially you know, around us. Okay, like that, and we need to apply that. Okay, daily, okay, in our daily lives also. Okay, thank you so much. I will end this vlogging or live. Okay, see you later. Thank you so much, Babush. God bless everybody. Bye bye. Wow. Okay.